Okay, so welcome to the how-to part 2 on gradients. So we have a question here, and before we get started, I'd like to review how I think about a gradient problem. So in math class, we learned that a gradient problem is where, or a slope problem was where I have 2 points, and I want to figure out the slope of the line between them. So in earth science, we're still going to be dealing with 2 points. Very often, these 2 points will be from some type of field map. They'll still have coordinate pairs, and I'm still going to be figuring out the slope of the line between them. The difference is what I like to do is I like to think of this as, instead of a graph, I like to think of it as a triangle. And so there are 2 parts of that triangle. There's the rise and there's the run. So what I want to be able to do is I want to be able to figure out those 2 parts of the triangle, and then I can do my problem. So I'm going to get rid of the graph idea, and I'm going to work with this triangle idea. So I'm going to move this over to the side just for reference. All right, so when we do a problem, what we need to do is we need to figure out the values of the points on our triangle. So as I said earlier, in earth science, we still have a coordinate pair. We still have an x and we still have a y. The difference is that the y is likely to be a field value, and the x is likely to be some type of distance or position. And what I mean by that is that this will probably have some type of distance unit label. All right, so as we read our question, what we want to be able to do is we want to be able to identify the values of our 2 points. And the information will be there somehow. We just have to be confident that we can find it. All right, so let's take a look. Let's see if we can figure out what's what here. So I'm going to get rid of this. All right, so a stream has a source of an elevation of 1,000 meters. Okay, so that's a distance value, but they're talking about elevation. It ends in a lake that has an elevation of 300 meters. So elevation is going to be one of our variables, either the x or the y. If the lake is 200 kilometers away from the source, then what is the average gradient of the stream? Okay, so let's talk about elevation versus distance apart. So we have kilometers away. That's another one of our properties, either the x or the y. So if I think about very often in our science, we're talking, when we do these problems, we're going to be talking about the slope of a hill or the gradient of a hill, how steep a hill is. So elevation is going to be likely going to be our field value, and the distance between them is going to be the x value. So in this particular case, we want to use the 1,000 and the 300 as y values, and we want to use the 200 as our x value. All right, so going back to the triangle, let's see if we can identify how we put together the triangle. So we have 2 different points. We have the lake, a stream source. So that's probably going to be uphill. The source of a stream is where the water is coming from. So this is going to be the source. And then the stream ends in a lake. The lake will be downhill, and that's where all the water is going to pool. So these are our 2 positions. So the elevation of the stream is 1,000 meters. So that's going to be a field value. So 1,000 meters. So this right here is 1,000 meters tall, or 1,000 meters high on a mountain. All right. The lake, however, is 300 meters up on the mountain. Okay, so what that tells me is that this level right here at the bottom is going to be 300 meters, and the top is going to be 1,000 meters. So if I want to find the difference between them, again, that's going to be the same thing as the run, y minus y. So I take 1,000 meters minus 300 meters, and I get 700 meters. So in this case, my run is 700 meters. So that's what I'm going to use in my math. Now that's going to be the field value. So that's going to be on the top. So I want 700 meters on the top of my fraction. I'll do that in a minute. All right, now they don't tell us the position of these 2 points. So in math, we would have a coordinate pair. The x would be the position of the point on the x-axis. We don't have that, but what we do have is the distance between them. So what if I take that 200 and recognize that the distance between the lake and the source is 200 meters or 200 kilometers? Now I know the distance between them. That's the run. So all I need to do now is I need to take 700 meters, and it's important to recognize the unit label right now. I'm going to take 700 meters, and I'm going to divide that by a run of 200 kilometers. And so if I take 700 divided by 200, I'm going to get something along the lines of 3.5, and my label is going to be that. Whatever the numerator label is divided by whatever the denominator label is. So I'm still going to have a label of meters per kilometer. And just to make everything color coordinated, just going to clean that up a little bit. That's it. So now what I'm looking for is I'm looking for 3.5 meters per kilometer. So my answer is going to be option 1. All right, so to review, I'm going to set it up like a triangle. I'm going to read carefully. I'm going to identify the field values of my 2 points. So the field value is going to be some kind of property that's being observed. Remember, a field is what we're observing and what we're ignoring. All right, so we're paying attention to the elevation of these 2 points. That's how I get the 1,000 and the 300. So again, this is still the 300. So I figure out the difference between those and I get the 700. That's going to go on the top of my problem. And the reason why it goes on top of the problem is right here, the change in field value. Change in field value in this case is the change in elevation. All right, so the 700 goes on top, and then the distance between the two goes on bottom. That's why the 200's on the bottom. And then I get my answer after I do my math. You can use your calculator, you can use your phone, you can use your computer. Doesn't matter to me. And that's one of the answers, so I'm all good. All right, so that's how we think this through using a triangle. I'm going to be doing this on every problem. I'm going to be thinking of it as a triangle and figuring out the values of each point.